Today I'll talk about mathematical basis of K-means clustering algorithm. It is part of my series of lectures on machine learning. This example I have taken from this internet resource. If this is our data set with these number of points and these are illustrated in 2 dimensions, initially we choose the appropriate number of centroids. In this example, I have selected randomly 2 centroids for this data set, and these are random selections. Then we assign each point to nearest centroid. So these points are assigned to this centroid and these points are assigned to this centroid on the basis of the distance measure. Usually Euclidean distance is used. Then we recalculate the centroid. So we recalculate the centroid of this cluster in red and we recalculate the centroid of this cluster in blue. So these are the updated centroids. Then we reassign all the points to the nearest centroid. So these points are very near to this centroid. So these are assigned to this cluster and all these points are assigned to this cluster. In the next step, we recalculate the centroid. So distance measure is usually Euclidean. I'll talk about other distance measures in this lecture. So cluster membership, how it is decided. So let us say if label Li is the cluster membership label for Xi point. So Li is equal to argument minimum J. J is the cluster. So it is the square of the distance or the Euclidean distance between a point and the centroid. So if this is shortest, then the label is Li is equal to J. How we calculate centroid? Let Xi is a point in a set of M points, centroid of K cluster. So if this is the cluster K and this is the cluster J, centroid of this K cluster is equal to the average of all these points with respect to the distance matrix used. Objective function is known as Lloyd objective. It is the argument minimum of the within cluster sum of square. Here Xij means it is to be calculated only if Li or the label of Xi point is equal to J. Then only we calculate the distance. So this is known as within cluster sum of squares. These are the other distance measures which we can use: Euclidean distance, Manhattan distance, and so on. This is very useful resource if someone wants to know detail about all these distance measures. How to identify the appropriate number of clusters? For this, we use the elbow method. So usually we use within cluster sum of squares. We can also use average distance. So initially, when we increase the number of clusters, the within cluster sum of square decreases, and then it remains almost stationary. So the last point of decrease is considered as the elbow point, and this is the appropriate number of clusters. In this example, I have taken from this source the 3, that is the number of clusters. If there are 3 clusters, so k is equal to 3 is the appropriate situation. So I hope this is the mathematical basis of k-means cluster is clear to all of you. Thank you very much.